Hello everyone, this is a revision playlist for Cambridge IGCSE Chemistry. Topic 1. States of Matter. The kinetic particle theory describes the three different states of matter and the changes that happen among them. As the name implies, particle tells you that all matter is made up of tiny particles. Kinetic tells you that those particles are always in constant motion. To describe the structure of different states, we need to describe the separation, the arrangement, and motion. I add them in one word: SAM. Separation, arrangement, and motion. Regarding separation, both solids and liquids have particles that are closely packed together. You may say they are touching one another. However, gases have particles that are far apart in comparison to solids and liquids. To describe arrangement, we can say that solids have particles that are regular. However, liquids and gases, both of them, they have particles that are irregular, which is the opposite of regular. You may say random. So both have random arrangement of particles. And in motion, solids have just vibrations. They are just vibrating in their fixed positions. In both liquids and gases, they have more freedom to move. So in liquids, they can move or slide over one another. In gases, even the motion is much more random and free. When a change of state happens from a solid to liquid, we call it melting. And from liquid to gas, we call it boiling or evaporating. And the difference between boiling and evaporating is that boiling happens only at the boiling point, while evaporating happens at any temperature below boiling point. So if you have a sample of water and you leave it for some time, you're going to find that the level of water is lower than before because water evaporates at any temperature below boiling point. Now, going from gas to liquid, that's condensing, and from liquid to solid, that's freezing. Moving directly from a solid to gas and vice versa, that's sublimation. To explain these changes of states, we may use heating and cooling curves. This is an example of a heating curve of water from minus 15 degrees Celsius to 110 degrees Celsius. On the y-axis, we have temperature, and on the x-axis, we have time. Adding more heat increases the temperature until it hits a plateau. Before that plateau, we have just solid ice. That plateau for water happens at 0 degrees Celsius, and we call it the melting point of water. And the reason why we have that plateau, despite adding heat energy to the sample, because this energy is used to overcome the attractive forces between particles. When all particles are in the liquid state, now temperature starts to rise again until it hits another plateau, and that second plateau happens at 100 degrees Celsius, and we call it the boiling point of water. And once again, the reason we have that second plateau because the heat energy is used to overcome the attractive forces between particles of a liquid. So generally speaking, in heating curves, you have two plateaus and you have three rising up lines. In the first going up line, you have just a sample of solid, and in the first plateau, you have solid and liquid particles, and in that second going up line, you have just liquid, and in that second plateau, you have liquid and gas particles, and in that last going up part, we have just gas particles. On the opposite hand, in cooling curves, you're moving from gas particles and then a first plateau where you have both gas and liquid particles, and then you have just liquid particles, and then liquid and solid particles, and then just solid particles. Here we're moving from a higher temperature down to a lower temperature. But generally, both curves can be explained using the same ideas of the kinetic particle theory. In the heating curve, that temperature is the melting point, and that second plateau is the boiling point. In the cooling curves, that first plateau once again is the boiling point, and that second plateau is the freezing point. Remember that moving from solid to liquid is melting, however, moving from liquid to solid is freezing. It's just all about the direction of a change of a state. However, moving from liquid to gas or gas to liquid is just boiling point. Once again, boiling and evaporation, both of them involve a liquid changing to a gas. However, boiling happens only at the boiling point. Evaporation happens at any temperature below boiling point. Also, boiling happens rapidly. Evaporation happens more slowly. It's worth noting that when you have impurities added to a pure substance, the melting point will decrease, however, the boiling point will increase. As an example, if you have a pure water sample, it will boil at 100 degrees Celsius and it will freeze at 0 degrees Celsius, but adding some salt to it will increase its boiling point to be more than 100 degrees Celsius at its freezing point to be below 0 degrees Celsius. Let's say -2 as a freezing point and 102 as a boiling point. Now, let's discuss the effects of temperature and pressure on the volume of gas. But before I discuss it with you, let me tell you why gas. Because simply, gases, they have much more spaces between particles, as we said earlier, so you can observe easily the changes or the effect of temperature and pressure on that sample of gas. When you increase temperature, particles will have more energy and they will move faster, and they will have less chance of interacting. It means they will not see each other more often. So they will not attract more and they will occupy greater volume because they don't have that much attraction. If we have a balloon as an example and you have it at a higher temperature, you expect the volume to be greater and vice versa. Now, when pressure increases, the particles will move closer together, and the moving particles are more likely to interact with each other and move closer together. So far, we have discussed the effect of temperature and pressure on the volume. So how temperature affects volume, how pressure affects volume. But let's ask how temperature and pressure both affect each other. We can say at higher temperature, the pressure increases. And the reason behind that, because at higher temperature, gas particles have more energy, so they move faster and they strike or collide with each other more frequently, and as a result, they will have higher pressure. Because as you know, the pressure of any gas in any container comes from the collisions of the gas particles with the inner walls of that container. Let's say we have a balloon. When particles collide with the inside surface of that balloon, it creates the pressure of that gas. In the older version of the syllabus, we used to discuss Brownian motion, and you're going to find lots of questions on Brownian motion. It's okay. Brownian motion is simply the random motion of the fluid particles. Diffusion happens when particles move from a region of higher concentration to a region of a lower concentration. Diffusion happens only in fluids, and when I say fluids, I mean liquids and gases. But diffusion in liquids is much slower than in gases. What about solids? Diffusion does not take place in solids at all, because particles in a solid cannot move from place to place. Remember, the motion in solids is just vibrations, so particles just vibrate, but they cannot move freely from place to place. So diffusion happens in liquids and happens in gases. Let's take an example of diffusion in liquids. Let's say that we have a potassium manganate 7 crystal, and you put it in a sample of water. In the center here you have the crystal of the potassium manganate. The color is darker near the crystal, but eventually the crystal dissolves completely and the purple color spreads through the liquid. This is a very common experiment to demonstrate diffusion of gases. Here we have a glass tube and we have two pieces of cotton. The first one is soaked in hydrochloric acid, so it releases hydrogen chloride gas, and the second one is soaked in ammonia, so it releases ammonia gas. We know that when ammonia gas meets with the hydrogen chloride gas, they produce ammonium chloride, which is a solid. We see it in the form of a smoke, so we see it in the form of white smoke ring. The main idea here is the ring doesn't form exactly halfway between the two cotton pieces. However, it's formed closer to the hydrochloric acid, because one of the gases moves faster, and the gas that moves faster is ammonia, because ammonia has a relative molecular mass of 17, while hydrogen chloride has a relative molecular mass of 36.5. So ammonia is lighter, it moves faster, and it diffuses faster. Just as a kind of summation, you may say that the rate of diffusion depends on two factors: the molecular mass of particles and the temperature. With the molecular mass, the relation is inverse. It means when one increases, the other decreases. So when the mass increases, I mean in heavier particles, the rate of diffusion decreases. However, in temperature, the relation is direct. It means when the temperature increases, the rate of diffusion increases. I hope that helps. See you next time.